This is the beginning of the object oriented section to get you guys familiar with the first part of this. I'll pause and kind of elaborate at a couple points, but I'm not going to be able to communicate this any more succinctly than Dr. Kordowitz is. He's a very excellent professor, very good at what he does, exceedingly knowledgeable in many areas, particularly in and around programming of uh, various varieties that you can see in his tab. He's got um, many hundreds of programs that he's written for all sorts of things. So we're going to talk a little bit about object-oriented programming. What is it? We've kind of touched on this peripherally with the objects that we were creating in the GUI lesson. We're going to go back and do kind of some more complex stuff in the GUIs and things. And in order to do that, we need to have a little better grounding on what is object-oriented programming. It sounds scary and terrifying, and it's actually not. So we're going to include a bunch of this, and then I'll clarify when and where things need clarification.
I'm Dr. David Kordowitz, and welcome to Programming. Today we're going to be talking about object-oriented programming, which is a technique that allows us to modularize our code, which has become popular in programming since about the 1980s or 1990s. Let's begin. So far, everything we have done has been procedural. In other words, you follow a flowchart type diagram, and you work your way through your given program. This makes sense when we have things like repetitive tasks and other ways that we kind of go through a process. So think about a cookbook. Um, this is sort of how procedural programming works. You have a bunch of steps, you follow the steps, and you get to the result. The catch is that procedural programming looks at everything the same way. So basically, we have our steps, we follow our steps, and we get to the answer, but we don't really care about the data that we're moving around, and there's no special way to handle different types of data. So there's no real flexibility here if you want to do something different, such as working with specific types of data and having different treatment for different types of data. So in the late 80s and early 90s, the idea of object oriented programming came out and became popular. So, what I want you to think about with object oriented programming is the idea of what things actually are. So, for example, a fir is a type of tree. So, we can categorize things based on what they are. And in OOP, we're going to use what we call classes, and those classes are going to be what we call instantiated or copies of them created that are going to be our objects. So everything is going to happen within these objects, which allows us to individualize code based on what things are. Now, it's important to also realize that certain languages have added OOP as an after effect. So this is the primary difference between C and C++, is that C++ can be object oriented where C has no facilities to do that. So let's think about a real world object, and we're going to think about an elevator. So I want you to take a moment and think about an elevator. I know most of you probably, that's kind of a mundane thing to think about, but this is a real way of sort of capturing what object oriented programming is. So a question to you is, what is common amongst elevators? So there are millions of elevators around the world. What's common to them? Well, on modern elevators at least, we have buttons. So you push a button, it does something. This isn't true if you're talking about much older elevators, but we're going to kind of ignore those for now. Every elevator is going to have an elevator car of some sort. It could be a box type car, like it's made out of metal. It could be made out of glass. It could be anything, but they all have cars. They also all have some form of light because you need to be able to see what's going on so you know which button to press and you know where you are. What's not common between different types of elevators? Well, they're all different sizes. Well, that's easy because that's basically a property of the elevator. So when we think about it, we can set a property of an elevator to say this is how big it is. How much does it weigh? That's also a property of it. What direction's it going? Well, some are going up, some are going down. How long is the shaft? How far do we travel? Is this a 5-story building or a 100-story building? Those are going to be different, but in the end, the overall shell of the elevator is exactly the same. So what we have to think about is that is all the same, and the interface is always the same. So if you walk into an elevator in Japan, for example, you'll know how to use it even if you come from the US, because the general idea of how you interface with it is exactly the same. Now, the properties of it may be completely different, but the actual core of an elevator is an elevator. So what we can do is start classifying things this way. So when we think about different designs of things, we can use this general framework to be able to build things for programs. So let's for a moment look at what is a class. And a class is what we call an abstract data type, which means you create it. It contains what we call member variables. In MATLAB, we call these properties. And they have different names in different languages. And then we have what we call methods or member functions. These are functions that can operate on the data which is contained within the class. So in other words, your methods can operate on the properties to provide you with different information and to change things within the properties. Now, example of properties on an elevator would be something like the door. Is it open or closed? What floor is it on? What direction is it going? How big is it? How many floors can it go? Those sort of things. Our methods then will call back to those and do certain things. So, for example, is the door open? You will ask if the door is open, and the class will tell you, yes, it's open, no, it's not. Now, you may have one that's set door to open that tells it to open the door. What's the current floor? What's the travel direction? So these methods are actually functions that you can call that manipulate the individual data or read the individual data. Now, an important concept here is what we call encapsulation.
So you guys have seen an example of how this works in practice in what we were just working on with the graphic user interface and kind of taking our level of difficulty up significantly. I just didn't warn you guys that we were working with classes and that it was something you were going to need to understand a little bit more about. Remember that we worked with classes in Arduino, so we were doing classes in C++. This is why we have our void output for setup and the loop. These are classes. These are things that do stuff. Functions are classes that can do something. They process data that we give them. So you've seen this, we just haven't really hammered the terminology itself. But this is a very, very important concept. And so encapsulation allows us to take variables and do things to them in terms of functions and methods. So all of this has to sort of work together in combination. And that's why the reason why we're using that specific language for encapsulation is back to concepts that we've talked about, but we're going to pull all of that together across lots of different lessons. And this is an extremely succinct way to present it, and that's why I wanted you guys to see this as a reference point.
Encapsulation allows us to protect parts of the class, so you can protect some of those properties so that only the class itself can edit it or other classes can edit it. So if we think about it, in encapsulation, we have what we call public methods and public properties, which basically anybody who can touch the class can edit. So in other words, in MATLAB, we could go in and write a program and it can deal with the public members. However, it only can deal with the public members and not the other members, because private members, for example, can only be accessed by members of the class itself. So in other words, if you want to look at, say, a private member, you may need a public method to actually be able to pull that property back out. This is really important because it makes it so that you have to go through the right programming channels to be able to program what's going on inside the class. And you can't just go in and change the value of a variable, for example, on your own. This is good because it prevents there from being collisions and being errors due to multiple things editing the variables. The last type is what we call protected. Now, protected classes or protected methods and protected properties are accessible by classes that come from the same parent or base class. So what the idea is that we're going to talk about is how we can derive new classes from existing classes. This is really actually kind of a neat process, and it allows you to go through your development and not have to write every single thing every single time. This encapsulation method allows classes that are derived from your class to access methods within your class.
So here, another way to look at this concept is the public is information about the buttons, about the placement of the windows in the graphic user interface examples and things like that that we were looking at. Public is, you can think of it as being sort of way out in front of the way out in front. It's out in the it's in the front display window or something. It's something that everybody passing by can see and interact, make faces, put their hands up on the glass and blow kisses or whatever people do when they're walking by a display. So public is an open box where anybody can put stuff in, take stuff out, and mix stuff around that's in the box. Private is like these boxes that are closed. And I think this is why Dr. K really liked that photo as an example. So private is something that's inside the box. You can move the box around. You can stack the boxes on top of each other, but you can't reach into the box and make changes. The box takes something in and puts something else out, and it's sealed and you can't get inside. Obviously, except when you're editing the code that's inside that particular class. So there's different types of encapsulation that we need for different reasons. Some of the programs that we've done, you need to be able to pull data in and do something with it, sometimes in multiple different ways. That private nature of the class itself is pretty important. We want to be able to keep some stuff private based on different processes that we do. Maybe there's lots of equations and things that are highly specialized to perform a specific function or solve a specific problem, and those need to be kept separate from the other processes that you're going to be doing. So you have a box that contains a series of equations to solve. You have another series of boxes that feed data into that box of equations to test different scenarios or something. There's a lot of different reasons why you want to be able to do this. The public boxes are important because you do need to be able to have a user interact with that data set and be able to run different scenarios, be able to test different sets of variables, be able to analyze data multiple different times from different angles. So you are often using a combination of public and private. The biggest benefit that he mentions there actually is that the protected class allows you to do some parent-child cloning of some of the things that are going on. That has a lot of utility. We're probably not getting very far into that this semester, so it's not going to be a huge focal point. I just wanted to highlight that for a second.
So let's think about this idea. We have what we call inheritance. So let's take a moment to think about a duck. And a duck is a type of waterfowl. So what do you think of first when you classify a duck? Do you say it's a bird? Is it a waterfowl? What is it? So if we think about the hierarchy, right, we start with a bird, and a waterfowl is a type of bird, and a duck is a type of waterfowl. So we can say that, well, a duck is going to have the general characteristics of a waterfowl. Now, it may be a little different than a standard waterfowl, but it's going to have the general same characteristics. And then a waterfowl is going to have more characteristics than, say, a bird. So it's going to be slightly different, but a bird is the most generic we want to get. Now, if we really wanted to, we could go up one level and say animals, or say, warm-blooded animals. And you can keep going up and being able to inherit information from the previous levels. So when we think about it, this is really useful because we can bring both properties and methods from existing classes that we want to derive from. In MATLAB, we call this subclassing. In a lot of other languages, we're going to call this either derivation or subclassing or class inheritance. Another concept which we have to think about is what we call polymorphism. And the general idea of polymorphism is that we don't really need to instantiate the upper level classes because our class that we have created can contain all the information we need. Therefore, when we create a duck, if it's inherited information from waterfowl and bird, we're kind of agnostic to that. We don't really need to know that a duck is a waterfowl is a bird because it really honestly doesn't matter as far as the compiler and or interpreter is concerned. So we just don't mess with it. We just can call duck, and duck will do everything we need it to do. So let's take a look at a quick example using a deck of cards in MATLAB. We're going to develop the classes as well as the subclasses to be able to get some interesting information out and be able to see how this works. So in MATLAB, classes fall into their own class files, where in some other programming languages this isn't true, such as C and C++. We can use our classes in the same files that we've already been creating. In MATLAB, the first line of a class file is going to be classdef, followed by the name of the class. So for example, let's use card. So it's like a deck of cards. Now, it's important to note that if you want to, you can go to the new menu and create a class right here. However, doing that is going to fill in some of the information you need and may not be applicable to the type of class you're trying to create. So we're going to call a card what we call the base class. So a card is just going to be a card. It's not going to inherit from anywhere. So the first thing we need to do here is include some of our properties. So we're going to type properties to define our properties. And in this case, I want to set my access to these properties to private. The reason being is I don't want anybody from the outside world to be able to change things about my card. So for example, something that we may care about is our suit and our rank. So the rank being the number on the card. So these are examples of some private properties that we want to maintain. So then we can do end to end our properties. Now we need to create some methods to operate on these. So the way we're going to start is what a method that we call the constructor. So we're going to do methods. And if we're going to keep it public, we don't really need to worry about telling it that we want the access set to public. So the first thing we want is what's called the constructor. The constructor is called when you first instantiate the class. So it's going to set the card up. So let's say that we're going to call it CD for card is going to be equal to card. And we're not going to take in any properties. So we need to define this as a function. And so we have our CD, which is going to get created. We have our card, which is going to get created. And so we need to say, okay, well, CD dot suit, which is going to tell me the suit of the card is going to be equal to, and we have 4 suits, so basically we have the numbers 0 to 3. So we're going to say 3 times rand, and we're going to say round that. And so what that's going to do is that's going to set our suit to be equal to 3 times a random number. Now for our rank, we have 0 ace through king, which is 13. So here we're going to want to get 13. So we're going to say round of 12 times rand plus 1. And what that's going to do is that's going to shift it from 0 to 12 to 1 to 13, or ace to king, because we don't have any card that's worth 0. We can then type end here to end our function. So now we need to add a method to be able to see what our suit and rank are. To do this, we can simply say, okay, function, and I'm going to return S and R for suit and rank, and we're going to say that this is equal to get card. And then in our function, the first variable we need is going to be our card, because we need a way to be able to edit, to have that instantiation of the card present in our function. So we're not going to have to manually feed it that, but we need it to be there anyway so we can use it. Now all we need to do is say that S is equal to CD dot, and it's going to be suit, and that rank is going to be CD dot rank. We're going to end this function, and we're going to end our methods. Now, if we wanted to add something, for example, like a method to adjust the card value, we can now do a private method. And to do that, all we need to do is create a second method section. And we're going to say access equals private. And we can now say function, and we're not going to really return anything, but I'm just going to say, okay, so it's going to be function, it's going to be set card, and the first thing we're going to get is CD. Then we're going to get our suit and our rank. Now in this case, what we're going to do is we're going to say CD dot suit equals S, and so that sets our suit, and CD dot rank equals R. Now we're allowed to do this because this class here is the class that's instantiating. So in other words, we have the individual object here that we're manipulating the items within itself. Now this function can't be called from the outside world because it is private. Now the last line here is going to be to end the class def, and let's save this.
So what we're going to do as a point of practice is to go back and recreate this as it's been developed here, as a starting point. And I think he resizes his window here at an early part. So what you want to do is you want to grab a quick screenshot of this as a starting point. Then we'll look at his expanded view here, because he includes his get card. CD is the function that we're using in order to get the card. So in this sense, function definition within a class can be done in MATLAB fairly easily, maybe not necessarily a lot easier than some other things, but it can give you a lot of useful details. So it can give you a lot of key important information. So you want to know how to make this work, and you want to know how to include the, so he's got get card and then set card, but it's really, really important to get a handle on why you want these different method sections. So we're going to take that and we're going to create it, but we're going to go back and cover a couple of those key points again, because it's really, really critical to understand what it is that these are doing.
It's some methods to operate on these. So the way we're going to start is what a method that we call the constructor. So we're going to do methods. And if we're going to keep it public, we don't really need to worry about telling it that we want the access set to public. So the first thing we want is what's called the constructor. The constructor is called when you first instantiate the class. So it's going to set the card up. So let's say that we're going to call it CD for card is going to be equal to card. And we're not going to take in any properties. So we need to define this as a function. And so we have our CD, which is going to get created. We have our card, which is going to get created. And so we need to say, okay, well, CD dot suit, which is going to tell me the suit of the card, is going to be equal to, and we have 4 suits, so basically we have the numbers 0 to 3. So we're going to say 3 times rand, and we're going to say round that. And so what that's going to do is that's going to set our suit to be equal to 3 times a random number. Now for our rank, we have 0 ace through king, which is 13. So here we're going to want to get 13. So we're going to say round of 12 times rand plus 1. And what that's going to do is that's going to shift it from 0 to 12 to 1 to 13, or ace to king, because we don't have any card that's worth 0. We can then type end here to end our function.
So the first method that you have to do inside a class is this constructor. It has to be the same exact name. In order for it to function, it has to match the name of the class def, and you're going to want to save it. I think when he saves it, you'll see why he saves it this way. You want to save things very carefully when you're doing class definitions so that you don't get the classes misnamed and trying to call each other incorrectly and cause yourself errors. So there's a correct and incorrect way to do the saving. But you always start by setting up properties as part of just good discipline, setting up properties. Then each of these methods that we set up, just like in the GUI example, we had several instances of properties and methods both inside the class, which was the app. So we were doing an app class named, I forget what we were calling it, but it was test. I think I was calling it test 1 or something. So we're creating a class def of test 1 in order to do all of these operations and set up all of these properties for use later on. So we have to have what's called a constructor to basically build the class and set it up to be, this is the thing that makes the card a card, is the definitions using the suit and rank in order to clarify to the program what is a card, what does it mean, what properties does it use. That includes information about variable types and all sorts of things. We're not taking in an argument, and we're not doing additional math really inside of card to define what it is. We're just telling it the suit is going to be somewhere within this boundary. The rank is going to be somewhere within this boundary. And that's the end of our particular function for defining the card.
So now we need to add a method to be able to see what our suit and rank are. To do this, we can simply say, okay, function, and I'm going to return S and R for suit and rank, and we're going to say that this is equal to get card, and then in our function, the first variable we need is going to be our card, because we need a way to be able to edit, to have that instantiation of the card present in our function. So we're not going to have to manually feed it that, but we need it to be there anyway so we can use it. Now all we need to do is say that S is equal to CD dot, and it's going to be suit, and that rank is going to be CD dot rank. We're going to end this function.
So for this one, what we're doing is we're taking a couple variables. So we're defining these variables, we're storing these values to these variables, but get card is, he's defining this as a function simply to read the information that was created here in the constructor. So you need to feed it the data from CD in order for this function to be able to access the information that's created within the function. So if you don't include CD there, you cannot read the CD.suit and the CD.rank. This is critically important for how these functions work. So you can store it in an array, and he's creating an array here of S and R. So this is a 1x2 array of information, and this stores what the card is and how it fits within the whole hierarchy of cards. What kind of card is it? This is the full set of information that describes what subcategory of card this is.
And we're going to end our methods. Now, if we wanted to add something, for example, like a method to adjust the card value, we can now do a private method. And to do that, all we need to do is create a second method section. And we're going to say access equals private. And we can now say function, and we're not going to really return anything, but I'm just going to say, okay, so it's going to be function, it's going to be set card, and the first thing we're going to get is CD. Then we're going to get our suit and our rank. Now, in this case, what we're going to do is we're going to say CD.suit equals S. And so that sets our suit, and CD.rank equals R. Now, we're allowed to do this because this...
So what this is doing is creating, each time we do methods, we're creating another one of those cardboard boxes, which is what we saw here on the analogy. So we're creating another one of these cardboard boxes in our suit. Or we're creating another one of those boxes. So this sets some information about access being private. So we're going to put information into the box, and we're going to include CD from up above to include the top level class information. We're going to include S and R that we get from this other function that's getting information also from CD. This way it can access all of the information that's been generated previously in the other methods. If we don't put this information into the box, we can't use it inside the box to get or to set the card type. So this is basically allowing us to define a card based on the two key categories of suit and rank in order to define this is the kind of card that it is. So just like identifying a duck, we want to set, well, it's this kind of duck and or that kind of duck, or it's this color or that color. There's a lot of information that happens. So there's a lot of various things that we can do inside of this, but because the card is limited to the way that we've defined it up here, suit and rank, you could add another category of the back design for whichever company printed it, or there's additional things that you could do that are not common to all cards. They are unique to each set of cards, but that doesn't vary. That would be a constant value rather than a variable that changes with which type of card it is. So that would be a property rather than something that we've defined inside of one of these functions in order to flesh out our card class so that we can properly define and identify which type of card it is. We also are able to set a card within the set with this function. So hopefully that helps to clarify a little bit and not necessarily muddy the waters any further.
This class here is the class that's instantiating. So in other words, we have the individual object here that we're manipulating the items within itself. Now this function can't be called from the outside world because it is private. Now the last line here is going to be to end the class def, and let's save this. And you must call it the same thing as the class. So we're going to call it card. Now that this is saved, we can go ahead and run and try this out. So let's go ahead and create another file, and we're going to start with a close all, clear all, CLC. Or better than clear all, let's change this to clear vars. Now what we're going to do is we're going to create a class. So we're going to say our card, CD, is equal to card. Doing this should create an instantiation of the class. And if you notice in my workspace now, and let me drag this over so you can see, I now have a 1x1 card. So now let's get the values. So we're going to say S, R equals CD dot, and if I hit the tab, I get the fact that get card is the only function I can call, and get card doesn't take any arguments, so that's going to be it. And let's do display S. Well, we're going to do num, or bracket, num to str of S, and then we're going to add a space here, and then we're going to do num to str of R for our rank. Now we'll close this out and let's run this.
So this does several things. It's calling our class. It's saying CD equals card in order to call the class to a variable name. So you see that show up as soon as he runs this. It's going to recognize that we have card.m, it has to be named card.m in order for it to be the card class, because if you name stuff differently than the class, it won't work correctly, because don't ask questions you don't want the answer to. So we have to use the CD equal card. We could have called it something else, but this is going to be the least confusing, because you're going to get errors here if you go to call something differently than cd.getCard. This is the reason why when we were creating an app class, it had to be all of these commands in terms of app dot whatever the information containing thing was, the variables and values and things, the slider input, and then dot value. So we're looking for the value associated with this operator or input or data storage entity, or whatever inside of the CD, which is the top level class here, the card. So this is how all of this stuff relates and how the hierarchy of the calls and the commands and the things that you're doing are. And then at the end here, he's using the display. He could just say S and R and then get card without suppressing the output there. However, the display allows some constraints and formatting that you're not going to get by just unsuppressing the output here. So we want to use this carefully and intentionally this way in order to make it all make sense.
So if we run this, we find out that our first card is going to be a 2, which we could say is, for example, diamonds, and it's going to be 12, which is going to tell me that it is the queen of diamonds. If we run it again, we get the 3 of hearts or the 3 of spades or whatever you want to assign that class. And we can keep going, and each time we're going to get a different card. Okay, so now let's say we want to change our game, and we want to create an Uno card. Uno has slightly different restrictions. The cards go 0 through 10 instead, and then we have skip and wild and things like that. Well, for this purposes, let's say that it just goes 0 through 10 and has a suit or a color. So what we're going to do is we're going to make a new class that we're going to call Uno card. Now we're going to use the less than sign here to tell it that we want to derive this from card. So by doing that, I now have the entirety of that card class contained within this class without writing the first line of code. Now, we can keep our methods the same or keep our properties the same, but we need to change our constructor. So to do that, I can just say methods, and I could say Uno card, or UC equals Uno card, and this is going to be obviously a function. And so we're going to say UC equals Uno card. Now all I have to say is, okay, UC dot, and we want the Uno card to be our, we want our thing to be, our card to be the, say the suit. So UC dot suit equals, and then we're going to say UC dot suit is going to be equal to rand, 10 round of 9 times rand plus 1. Now what I want you to notice here is, really quickly, is that we're going to have an issue. So let's say rank. Actually, this is going to be our rank, and our suit is going to be equal to round 4 times rand. Now we're going to have an issue here with our encapsulation. And let's save this, and we're going to call it UnoCard. And what we're going to do is call it the exact same way that we called our previous card. So instead here, I'm just going to copy this and paste it. And we're going to call this UnoCard. And let's change this to UCD instead of CD. And UCD. And when we run this, we get an error. The reason we get the error is, if you remember, in our card, we declared our properties as private. Now, we don't really want to define them as private. Rather, we want to define them as protected, because we want our derived class to be able to modify them. So now if we come here and we run this again, this should run correctly. And now we get 7 in one of our classes, 0, which could be blue or red or yellow. So
there's another thing of very high importance in this example that he kind of glosses over. In defining this, he uses UC. So remember that I told you guys you were going to likely see examples of errors if you included a different way of calling it. So here he's changing it to UCD. So he can correctly get it to call using UCD. As long as you're consistent here and here, you can do that. You just have to be careful. It's good practice to use the same nomenclature that you're using within your class definition in order to get these to operate correctly. So changing them around and changing the variable names at this stage of your programming journey is probably not the best idea. But it allows us to call this, and then we have a card and UnoCard class, and we're able to use that function. Even though the UnoCard is not defining all of those pieces, the get card
now we're going to have an issue here with our encapsulation.
So the way that he's got this encapsulated is this is referring to the card as the top level class now that it's been defined and saved. It's not defined and saved and it isn't card.m. You're not going to be able to save this and then run it correctly because of some reference level issues that you're going to have. So you have to have all of those pieces in place in order for this to cooperate, just as a term in terms of mechanical functionality of the code. So the methods for this are going to be setting up rank and suit. The problem that he runs into is because that was private, anything that you do related to card trying to call for rank and suit can't get access to it. It's sealed away in a box and we can't get into it to access those functions. So it'll tell you that there's an error specifically in line 6 and it'll tell you where. So look for the error here.
And we're going to call it in UCD. Just to UCD instead of CD. And when we run this,
So this example, error in Untitled 2 at line 6. So it goes to call this Uno card. It hasn't even tried to access the function yet. As soon as you try to access this, there is a problem. And that problem is the access, and it shows up here. He doesn't show the entire error message, but it shows up here where it's highlighting these two as an issue because it says, hey, you can't access the UC rank. And this is the information that's really critical in diagnosing why it is that data wasn't accessible, why the script isn't running as you expect it to. Because even though those are saved correctly with the correct naming scheme for them to be classes, you still need to be able to access the information inside of card. And this is why that encapsulation is so important.
The reason we get the error is, if you remember, in our card, we declared our properties as private. Now, we don't really want to define them as private. Rather, we want to define them as protected, because we want our derived class to be able to modify them. So now if we come here and we run this again, this should run correctly. And now we get 7 in one of our classes 0, which could be blue or red or yellow. So the general idea that we get here is that we can say that an Uno card is a card. So an Uno card is derived from a card, which means we get all of the properties and all of the methods. However, if we set the access to private, we don't have access to those in the derived classes. However, and if we set it to protected, we have access in the derived classes. And then if it's set to public, we have access to it everywhere, including the command line. This concludes the Introduction to Programming for Engineers course. I'd like to thank you for all the time that you've put into these videos, watching them and practicing your skills. I'd like to wish you luck into your future programming endeavors, and thanks again. Hello.
So we've got the information that we need from this process in order to get a handle on, for instance, why some of these things are the way that they are. So we're defining test app 1. This does a little bit different setup, and this is much more detailed, but it inherits the apps.appBase. So this is the parent class under which all apps fall. So it derives from this. So there's no actual wizardry here. It just helps to have a context for what all of this actually is doing. So we start out by setting the properties. So all of these things are figures, UI control. UI control is a specific thing relating to the MATLAB app base. UI control, sliders, numbers, buttons, grid layouts, gauges, all that goodness. The properties, access, private here. There's a few different things that are going on, and a few different things that we need to understand about how that works. So in this case, the panel width is the only property that they need there, and this is private. The properties for all of these have to be public. Why? Because if they aren't, if these aren't public, you can't access them in order to actually interact with the interface. You couldn't change those variables, move those sliders, etc. So they have to be accessed public. Properties, in this case, private, is panel width. We can change and update this. So if we go to design view, that number now changes, but we have to save it. So that number would update. Then we start callbacks, which are just methods. They're things that we're doing, and function definitions. So just like what we were looking at, but there's a reason why I didn't try and teach you all of the core of what is a function and what is not in this context, and why are we doing this sort of thing. Event is a specific type of data that is defined at the top level, MATLAB apps, app base. So then we do our actual code operation and the end. So we can collapse this down in our for loop. We can collapse down the whole plot results button pushed, so that we can see the other code. So update app layout. This is the reason that we're able to do the things exactly the way that we are. This helps to change and update the app in order to make this work, so that as you're running it, this bit of code allows you to say starting value of 1, increment of 2 to 50, intercept -6, exponent of 3, plot the results. So this, I can't change the width here, that's fixed, but I can interact with these, and I can interact with zoom in and out and rescale or shift, all because there's a couple other things that you can do as well, some zooming and panning and some other things. Panning is quite interesting. There's a lot of really powerful stuff that you can do with these tools. You can do format changes and all sorts of things. You can't edit like the names of the axes or anything. You can't edit the name, but the app layout updates. I can resize the app window because the app layout updates. So there's all these little things baked into the GUI designer and the app designer in order to make stuff easier. So that one's an important one. Then there's some more things that it needs to do. And this is the initialization of components. So setting up the UI figures, the positions, the grid layouts, all of those sorts of things. The label positions and all of the positions of everything. This is all required to create all of that from 71 all the way to 180 is just to create the visual representation of this app window. So it takes on the order of it takes on the order of 100 lines, just a little over 100 lines, 110 lines to create just the interface. Is about 110, yeah, it's 105. Call it 105 lines. No, it's about 110. Yeah, it's 110. 70 to 180. So it's 110 lines just to create the visual window. So app creation, deletion, you just do more methods. In this case, public, because you need to be able to access this stuff. It's going to call test app one. It's going to create the components, and it's going to make the app run. And then if the number of arguments equals 0, it's going to clear the memory so that it's ready to do the next thing. And then code that executes before app deletion. Yeah. So there's a lot of moving pieces to the way this stuff works. So the properties and some of these things are all really key to understanding how some of this works and how the classes come into play and why these work the way that they do. So there's a lot of information, a lot of information. So I'm going to call it here for this particular lesson. I expect you guys to have to kind of go back and rewatch a couple different times to actually pull everything out of it, especially before you go trying to put it into practice and recreate both of those card classes, which is what I want you guys to do next. That's going to help get you some practice with hands-on creation of classes now that we have a better understanding of what these classes are. It's just creating an object, telling it what it is, and then telling it what it does and how to do it. That's the dramatic oversimplification. So if you can get a handle on that, you can get a handle on a lot of this stuff and really make some cool stuff happen in MATLAB. And especially with something like the App Designer, you can create something really powerful and incredible in so much less time than it used to take to create all of this. Like it's just absolutely the power that is in your hands with this kind of quick creation tool is utterly ridiculous. Yeah, utterly ridiculous. I can't even explain the number of hours and hours and hours it took us to create stuff like this from scratch and troubleshoot all of the code line by line by line by line with our 300, 400, 500 line programs. Yeah, I wish you guys understood the degree to which you have like a golden spoon to feed you this stuff with. But you really, really do. So don't squander it. Use it as a powerful lever and use that lever to get to do cooler stuff faster with more excitement. And then the more that you work with it, the better you can actually do all of this stuff. And yeah, there are so many layers of possibility that you can access with this kind of knowledge and capability. So very exciting stuff. There's a lot more that we still need to cover, especially as we go to prep for quiz 3, which will be next week. So that will be scheduled for the week of Thanksgiving, because that's what's going to make the most sense to try and capture most of this information rather than trying to push it later in the semester. I really think that's going to be the best use of this. And then we're going to start working really heavily on the last couple CLC projects and things that are going on as we're coming back. So a lot of interesting stuff going on, and I think we'll be able to make some pretty good headway pretty quickly.